Greetings and welcome to the introduction to astronomy. In this video, we are going to talk about two things. We are going to talk about stellar populations, different types of stars, and how they formed over the course of the history of the galaxy. And that will lead us to looking at the formation of our galaxy itself. So let's go ahead and get started. And what we find with stellar populations is that there are essentially two types of stars in the galaxy. Most stars that we see are what we call disk stars, meaning that they are in the disk of the galaxy. And they orbit along in roughly circular orbits that go around the center of our galaxy in a flat plane. So much as the planets orbit around the sun in essentially a flat plane, so do the stars in the galaxy. And those are what we call the disk stars. However, there are also halo stars that orbit in the galactic halo. Instead of following the galactic plane as do other stars, these go in all sorts of directions and at all sorts of eccentricities. So sometimes very eccentric orbits, very squashed orbits. So quite different than the stars that we see in the galactic plane. And we're going to see that this can tell us something about the early history of our galaxy. So what does this mean with two types of stars? Well, what we see is that they were divided into two stellar populations by Walter Baade when he looked at the Andromeda galaxy, and he called the stars population 1 stars those in the disk, and population 2 stars were the halo stars. And we found that there is a distinct difference between these two populations. Population 1 stars are in the disk. They have circular orbits. They have a very wide range of ages, from very old stars to very young stars. And they have a high metal abundance. And I should take a minute here to explain what this means and to remind you that to an astronomer, a metal is anything that is not hydrogen or helium. So ignoring hydrogen and helium, any other element is considered a metal. So things like carbon and oxygen and silicon are all metals to an astronomer, anything that is not hydrogen or helium. Now a population 2 star here are in the disk and the halo. They have eccentric or tilted orbits. They are all very old, so not a wide range of ages, and they have a very low metal abundance. They are almost all hydrogen and helium. Now, of course, this is an idealized situation that there are two. If we consider the real world, there are really two really a variation between these two types of objects, but they are convenient to be able to study. So what does this tell us about the formation of our galaxy? So looking at the formation of our galaxy, how did the galaxy form in the first place? Is it similar to the formation of a star, but on a much larger scale? That is one way of thinking about it. And essentially it means it's what we kind of call the monolithic model, where the galactic cloud, as we see here in figure 1, is collapsing in to form a disk. So as it collapses, the very first things to form are the globular clusters. Once they've formed, they are actually in orbit, so they remain where they are. They will just continually orbit around the galaxy, but they do not continue the collapse. The collapse continues over time, and the galaxy will spin faster and faster, and material will concentrate towards the center. So you can think of this like star formation on a massive scale, that the sun would be what forms at the center and then the planets around it. In this case, we get the center of our galaxy, a high concentration of stars and our supermassive black hole. And then the rest of the stars form in the disk around it. So we can look at that it was old stars and the globular clusters that formed. Once they formed, they remained in the halo. It was only gas clouds, the gas, that would collapse down into the disk to form future generations of stars. So the halo on the outer regions up here and down here would have had no gas and dust. So it would undergo fragmentation, that things would slowly break apart. You'd break apart this gas into larger pieces that are the size of clusters, and those would go into star-sized pieces, and those would eventually go through the types of star formation that we've looked at in the past. Now, if we look at another way of thinking about this is what we call the multiple merger model, that there may have not been a peaceful formation of the galaxy. Essentially, what we have been finding now is that galaxy collisions are incredibly common. They occur all the time. For example, our Sagittarius dwarf galaxy and some others are actually being torn apart by tidal forces of our Milky Way galaxy. So if we look at our Milky Way here, we see tidal streams, which are leftover bits of that galaxy that has been disrupted by passing too close to our Milky Way. So we have several different tidal streams that we see here. And those are those remnants of those galaxies, those small galaxies that have been torn apart. And what we find is that galaxies then grow through collisions, that what starts out as a very small galaxy can absorb other smaller galaxies and continue to grow in size, eventually becoming the galaxies that we see today. And we see the evidence of this with multiples of these streams seen in the halo of our Milky Way. So what are the results of some of these collisions? And what we see is that the collisions serve to stir up the stars and gas in the disk. The disk becomes thicker and stars form in this thick disk, whereas the gas will settle back down to a thinner disk where the newest stars form. So we start to get various ranges from the halo with the oldest stars to the thick disk down to the thin disk where the newest stars are forming. Collisions are coming. So there are more collisions. And what we see is that the Canis Major dwarf galaxy is gradually merging with the Milky Way and will eventually become incorporated within the Milky Way itself. On a larger scale, the Milky Way and the Andromeda galaxy are on a collision course and will merge together in a single galaxy in 3 to 4 billion years. And what we see here is an artist's conception of what that would be. We see our Milky Way, which we're used to seeing here. And as it approaches billions of years from now, the Andromeda galaxy will continue to get larger in size. So not actually changing its size, but it will be becoming much larger. So the Andromeda galaxy here will look much larger in our sky, and we'll see this gigantic galaxy that would be approaching closer and closer. And eventually the two galaxies would collide together and merge into a much larger, probably an elliptical galaxy. So let's finish up as we do with our summary. And what we find is that first of all, we talked about two different types of stars. We had the population 1 stars in the disk and the population 2 stars in the halo. We think that galaxies could have formed by a larger version of the process by which stars formed, but also that collisions are very important. Collisions between galaxies are really important for explaining the structures that we see in our galaxy today. So that concludes this lecture on stellar populations and formation of the galaxy. We'll be back again next time for another topic in astronomy. So until then, have a great day, everyone, and I will see you in class.